So we're going to do a problem solving question related to composite solids. I guess I want you to think of problem solving as, we're always having to try and find our way to an answer. Sometimes we won't find it the easiest way straight away, but that's okay. All right, so there's not always one way to do things. I'm just going to demonstrate a particular way. So I want to look at this question, which is on your slideshow. It says, take a wooden cylinder with height 25 centimetres and diameter 9 centimetres. If this cylinder was ground into sawdust and my screen timed out, hang on a minute. If this cylinder was ground into sawdust and compressed to form a wooden cube, what would be the length of each side? So basically, we're starting with a cylinder with its particular dimensions. It's being broken up into tiny pieces and reshaped into a cube shape. But then we want to know, what are the dimensions? What are the lengths? What are the widths? What are the height? Okay? All right. So let's start. If something's being taken from one shape, being broken up and made into a new shape, we're really talking about the space inside. So we're talking about volume. So we're starting with, excuse me, I'll just try and angle that a bit better. We're starting with a cylinder. And it gave me the dimensions of 25 centimetres tall and 9 centimetres across the diameter. Okay, so I want to know what the volume of that cylinder is. Okay, now remember, volume is equal to the area of the base times the height. So the area of this is a circle. So it's the area of a circle times how tall the circle is. Okay, times the height. You'll notice that I'm doing this a little bit of a shorthand way. I'm not finding the area first and then multiplying height. I'm kind of joining it all up. And you are allowed to do that if you prefer. So the area of a circle is pi r squared times by that height. So pi times, the diameter was 9, which means my radius is half of that. So 9 divided by 2 is 4.5. So I'm going to replace my r with a 4.5 squared. Times by, now height means the distance between bases, so here to here, which is 25. If I put that all in my calculator, I get 1,590.431. Just take a second and check if that's what you also get. Now with volume, we're talking about cubic units, so we're talking about cubic centimetres. So that's the volume of the cylinder. So that's how much space was in the cylinder. But the contents of that space, which in this case is wood, was broken up into small pieces and reformed into a new shape. It was formed into a cube. Okay, and the cube, what we don't know is how high it is or how long it is or how wide it is. But we do know that whatever this is the same as this, is the same as this, because it's a cube. So length and length and length are all the same. Well, length and width and height, but they're all the same. We also know what the volume has to be. So we can say a volume of a cube is equal to length cubed. Okay, the volume of this cube is equal to 1,590.43, and it equals whatever the length is cubed. The question is, I don't want length cubed, I want length. So I've got to find a way to undo cubed. So the opposite of squaring something is square rooting it. So the opposite of cubing something is cube rooting it. And there should be a button on your calculator that has this sort of shape with a 3, or even with a box where you can put the 3 in it. So we're going to put in the cube root of 1,590.43 is equal to L. And if we pop that in our calculator, we should get that the cube is 11.67 something. Okay, what was it? Well, we're talking in, we've gone from cubic centimetres, so we're talking centimetres. So therefore, the cube's length is 11.67 centimetres. You could have a quick check of that by multiplying it by itself 3 times and seeing if it got roughly to that point, which it should. So there's some problem solving. Problem solving often requires us to get some information and then put that information in a new place. In this case, we put it in the volume place to figure out the length. Good luck.